Okay, so today I'm going to talk about Thevenin and Norton equivalency, the DC version of that. And essentially what Thevenin is, there's Thevenin resistance and Thevenin voltage, okay? And what it is the reduction of a circuit like that into a single voltage and a single resistance, okay? So I wrote, I made some extra wires, right? A and B are just, there's no branch, it's just extra wires, so it doesn't affect the circuit, but we're going to find the voltage Thevenin across A and B. And we're going to find the total resistance of that circuit as well, which is going to be R Thevenin. And so there's actually three ways to find R Thevenin, okay? The first one is to deactivate your independent sources and combine resistors into one. I like that one the best. Whenever I can do that one, I do that one. The second one, right, is to deactivate the dependent sources and use R equals V over I, to find V or I, right? Whichever one you don't have, you're going to find it. Because if you know two variables, you can find the third. If you can find V Thevenin and then use this to find I Thevenin, or that current, you can find the resistance. And the third one here is to short A and B, or A to B, right? So we draw a line from A to B and find the current through the new short, right? We call it ISC, right? And we find the current through that wire. This one, the third one, works every time, okay? Even though it works every time, I still like to do the first one when I can. And so I wrote a note up here that the deactivate the sources, that word. So what we're going to do is we're going to short voltage sources and we're going to open current sources, okay? So that's how you find R Thevenin. Those are the three ways you can find R Thevenin in any circuit. But V Thevenin, you just gotta find it. V Thevenin, you use the skills that you've built throughout the class. Mesh, loop, nodal, KVL, KCL. Just name a few. Everything that we've learned, try to use those skills to find V Thevenin. In this case, I'm going to use the most simple one, V equals IR. Just that equation. I'm going to just feel around and try to come up with an answer for it. There's so many different ways to find it, and essentially there's no written rules like this, like R Thevenin. For finding it, you just gotta find it. And so we'll start with V Thevenin here. I'm gonna write it in blue. And so the first thing we're gonna do here is we're gonna notice that the voltage across A to B, right, is the same as the voltage across this resistor, right? Because of these are just wires, they're not branches. This is ground, okay? That's ground, we'll call it ground. And so the difference between this node and that node is the same across this resistor and whatever the voltage, V Thevenin. So keep that in mind. V equals IR. Here's a current source. Okay, current is going to flow this way and this way. Okay, a little bit's going to flow that way, a little bit's going to flow this way. There's resistance on each path, so it's going to break out into two. You could use voltage division to find it, but we actually don't really have to. let's start with, so the current of the source, okay, is equal to the current of I1 plus I2. Okay, that's fair to say, right? And so see, this is Thevenin is the harder one. Thevenin, you have to, like I said, you have to use the skills that you've built. You know, I mean, you just gotta throw stuff at it. Right. Okay. And so our source here is 6 milliamps. We're just going to fill that in, fill in as much information as we can, so that we can eliminate some variables. Okay. Our current right here, okay, is defined as, we can use V equals IR right here. The I1 is going to be equal to V Thevenin over 5 ohms. Okay? Bear with me. All I'm doing is rearranging this equation, okay? And I'm plugging in numbers, or more specific variables for it. So the current right here, right, the I1 that goes this way, is going to go through this resistor, right, which is also V Thevenin, as we explained earlier, okay? And so the current is equal to V Thevenin, which is the voltage across this resistor, over the resistor, okay? So we can replace this I1 with V Thevenin over 5. So we're going to do it. V Thevenin over 5, okay? Now we're going to do the same thing for I2, for the second current. Okay? And the voltage, you might ask, right, is the same thing. It's V Thevenin. And I'll explain why. If we were to combine these 3 resistors, right, because this I2 is going to go through this entire part of the circuit. If we were to combine them all, if we combine them into one resistor, that resistor would be 7 ohms. You can check my math if you'd like, but that would be 7 ohms, this resistor. And it's one resistance. No, I'm getting off track. So this node is connected to the ground, right? Try to envision just this part of the circuit. That resistor, this source, and that resistor. This node is the ground. Okay? This node is a different node, right? With a different voltage. There's a voltage drop, or a voltage change between this node and that node. And that voltage change is V Thevenin. Okay? It's V Thevenin across this, it's V Thevenin across this, and it's V Thevenin across this. So that's why we can use V Thevenin on I2 in that simple little equation. I actually just did my second step too. I explained the resistance as well. When you combine all 3 of these things, you get 7 ohms, like I said. You get 7 ohms, like I said. And so that is the total resistance of I2 on this half of the circuit. So we can write 7 ohms right there. And we just defined what I2 was, and so we can replace it with V Thevenin over 7. Now we have numbers with a variable, one variable that we can find. So we're going to find it. Okay, so what I did here was combine these 2 fractions that you see and moved V Thevenin out, and I did a bunch of math to get down to an answer. which I put right there. And so that's the hard part. It's out of the way. Okay, so now we're going to find our Thevenin. Okay, we just found V Thevenin, we're going to find our Thevenin. We're going to use my buddy, the first one. Okay. And so what we're going to do is we're going to deactivate the independent sources and combine resistors into one. Find our Thevenin. That one resistor in the end is going to be our Thevenin. You know, it's just we're going to sum them all up, and it's just going to we're going to have one left. So that's the total resistance because there's only one there. And so if there were voltage sources, we would short them out, and then since there's a current source, we're going to open it up. So I'm gonna do that right here. Just opened up our current source. I'm going to rewrite this entire thing down here with all of these summed up. Okay, there's another video that I'll put in the description describing how to combine resistors. But for now, I'm just gonna put 12 ohms. When you combine these, all that's left here is a bunch of resistors in a circuit. You know, that's easy. You can combine them. We are very capable of doing that. And so when you combine them, it equates to 12 ohms. Okay, with this open circuit right here, which is our current source that we had originally. Okay, and so using this first method, we combine this big circuit into one resistor, which is in fact our Thevenin. And so in the analysis of this circuit here, we can find both V Thevenin, right, the voltage drop between A and B, as well as R Thevenin, the total resistance of that circuit. That's it.